So for this practice exam, the first question wants us to find the following information about the quadratic function that is given and then make sure we graph it. So our first problem, f of x equals -3 parentheses x minus 1 quantity squared minus 4. We need to find the a, h, and k. The a is just the number out in front of the variable being squared, so that's -3. The h is inside the parentheses with the x, and it's opposite of the sign because there's an x minus h, so there's already a minus, so my h is just +1. And then the k is on the outside, which is -4. Put those two things together for the h and the k, and that gets me 1 comma -4, which is my vertex. Now, before you find the x-intercepts and the y-intercepts, which can sometimes be a little bit of a long process, I want you to use the information that you just got with your a, h, and k and plot your vertex at 1 comma -4. And then I want you to use your a. The a that is -3 tells us I can go right 1, and because my a is my compressor stretch, like we learned in previous lessons, I'm going to go down 1, 2, 3. And left 1, and instead of going up 1, we go down 1, 2, 3. We go left and right 1 and up and down a, whatever my compression stretches. So I can already see some information that's going to help me. I can see right here we have a y-intercept. I can see it, it's right there. I accidentally got the y-intercept by going left and right 1 and up and down 3. So I can go ahead and plot that 0 comma -7. I can do that without actually any extra work. Now I'll show you how to do it the long way just in case you don't accidentally get it, because on the test you might not accidentally get that one. And then there's another thing I can tell. I can tell that my graph is going to be pointing downwards and the vertex is below the x-axis. So this graph is never going to cross the x-axis. So I automatically can look at this and write, well, none. There's never going to cross the x-axis because it started off below the x-axis and it's pointing down. It's never going to cross. So the x-intercepts and the y-intercepts, which are often take a little bit of extra time, we kind of got for free just by looking at my a, h, and k. Now, you might not get that for free on every single problem, so I'm going to show you the long way of doing this. To get the x-intercepts, what we're going to do is we're going to set the whole function equal to 0 and then solve. So if I set the whole function f of x, which is -3 parentheses x minus 1 squared minus 4, equal to 0, and then I solve, I'm still going to get the answer that there aren't any x-intercepts, but I want to show you the way you would do that. You'd set the whole function equal to 0, move the 4 over, and I'm going to divide each side by -3, which gets me x minus 1 squared equals -4/3. Then I'm going to take the square root of both sides, and that leaves me with just x minus 1 on the inside equals plus or minus the square root of the square root of negative. At this point, I know I have an imaginary number, some sort of I with other terms around it, but I, we know, is not real. So because we have an I, we know that the x-intercepts are not real, which means I don't have any real x-intercepts. Therefore, I'm allowed to put none here. Okay? So that's how you'd find the x-intercepts the long way, if you didn't happen to already see it on the graph. But please take that extra moment to plot the a, h, and k and see if you can't get something for free. It's going to save you a lot of time. To get the y-intercepts the long way, in case you didn't accidentally get this one for free, you'd plug in 0 to f of x. So if I did f of 0, it's going to be -3 times 0 minus 1 squared minus 4. Now, don't be hasty here. Actually work it all out, because sometimes people are like, oh, that's just going to be 0. No, it's not. Just because you plug in 0 doesn't mean you're going to get an answer of 0. 0 minus 1 is -1. -1 squared gets you +1. So I have -3 times +1 minus 4, which is -3 minus 4, which is -7. Again, we already had that information, so if you didn't want to do it the long way, by all means, don't do that. But if you need to, then now you know how to do it. On our next problem, part of this problem, we have the axis of symmetry. The axis of symmetry I could graph here. You don't have to graph that part, but if you want to see what it looks like, that's where it is. The axis of symmetry is x equals, it's a vertical line, so it's a vux, x equals 1. By the way, it's always going to be x equals h, okay? The domain is always going to be all reals for any polynomial. So I'll put that over here so you can remember that. The range, in this case, it can go down forever, and the max height we have is at -4. So my range is -infinity until -4. Now the -4 gets to be included. So this range is always going to be -infinity up until k, or k to infinity, depending on if it's pointing up or down. And this red point over here on my graph is a maximum value. The vertex happens to be a max because it's pointing down. The max value happens at -4. That is as high as the graph is ever going to get. When does it happen? At x equals 1. So this is always going to be k at x equals h. Just some patterns to look out for. Just if you're trying to see patterns here, notice the axis of symmetry and the max-min value are the same. And also the value in the range is the same number in the value of the max or min. Okay? So those are just some things that you should kind of notice that are always popping up the same. On our next problem, we're basically doing the same thing, but this problem wasn't written in the standard vertex form, so I can't tell you what the h and k are right off the bat. I can tell you what the a is. The a is always the number in front, that's just 2. In order to find the h, I'm going to use the formula -b over 2a. So my b is 8, so I have the opposite of 8, because the 8 is positive in my function, but there's a negative inside the formula, that's why it's -8 over 2 times 2, so that gets me -8 over 4, which is -2. Now in order to find the k, there is a long formula for it, but I never actually showed you that long formula. In fact, I don't think I've ever memorized it, because once you get h, which is an easy formula, all you have to do to find k is just plug in the 2 into the original function, because we know the h and k are an ordered pair. So if I can find one, then I can simply find the other by plugging it in. So f of -2 is 2 times -2 squared. PEMDAS says do my parentheses, my exponents there. So now I am taking 2 times 4, which is 8. 8 times -2, which is 16, -16. So 8 minus 16 is -8, plus 6 is -2. Okay, so I have a point at a vertex at -2, -2, putting the h and the k together. Now, as I said on the previous question, sometimes you get extra information for free just by plotting what you have so far. So let's go ahead and do that. I've got a vertex at -2, -2, and I have an a of 2. So I'm going to go right 1 and up 2, left 1 and up 2, because I always go left and right 1 and up and down whatever my a is. And right now, accidentally, I got x-intercepts for free. So you can just take those x-intercepts, which are going to be, what is that, -1, 0 is one of them, and the other one is -3, 0. Those can be written in either order. Okay, for the standard form, I'm going to put my function in standard form, which I'm going to write the general standard form up here. So a x minus h quantity squared plus k. So who's my a? Well, in this case, my a is 2. Parentheses x minus, because there's a minus in the formula, but then I have a -2 for my h. So minus a negative is actually plus 2. Okay? And then plus k, but my k happens to be negative, so that's -2. Notice the h had to change its sign. Okay, so I got points for my vertex, my standard form, and my x-intercepts. And let's see, what if I didn't accidentally get the x-intercepts for free? Well, I could do this the long way, which is why I have space here for that. So I'm going to do f of x, which is either the original problem or the standard form. I like the standard form better. That way I can just use square root method when I solve. So I'm going to add 2 to both sides. So I get x plus 2 squared equals 2. Then I'm going to divide both sides by 2, which gets me x plus 2 squared equals 1. Now I square root both sides, and every time you square root both sides you have to take the plus or minus part. So we get plus or minus 1. And then the last step is to subtract 2, and I get x equals negative 2 plus or minus 1. When I split that up, I'm getting negative 2 plus 1 and negative 2 minus 1, which is negative 1 and negative 3. Look at those two numbers. We've seen those numbers before, huh? If you didn't accidentally get it for free, like we did when we used our A, H, and K, well then you can use the long method to get it. Now on this particular problem, if you got them x-intercepts from the graph, don't do it the long way, just move on to the next problem, okay? But in case you forgot how to do it, you can always do it the long way. The y-intercept I did not get for free here, did I? So I'm going to do f of 0, and you can do f of 0 to the original problem, or you could do it to the standard form. Either one's going to work. I'm going to go ahead and do it to the original problem. I think for me that's a little easier. 0 squared is 0. 2 times 0 is 0. 8 times 0 is 0. Plus 6 is 6. So I have a y-intercept at 0, 6. Alright, I also have an x-intercept. Remember we talked about the x-intercept being always at x equals h, so this h happens to be negative 2. I can go ahead and plot that graph it on my graph paper if I want. That axis of symmetry gets my y-intercept an extra point. Because my y-intercept is on the right of the axis of symmetry, when I reflect it over the axis of symmetry, I get another point on the left side of the axis of symmetry. So now I can graph that, and it's a pretty good graph here. Looking beautiful. We said the domain is always all reals. For any polynomials, and that's throughout a lot of the tests when you're doing polynomials. The range, the lowest it can go is at negative 2 inclusive. The highest we can go is infinity. Remember that's always going to be k comma infinity or negative infinity comma k. And then the max value is negative 2, and that occurs at x equals negative 2. By the way, that's always k at x equals h, okay? And that happens to be a min this time. It's a minimum value, so not a max.